All right. So make sure you project. All right. How's it going, everybody? Good. My name is Vince. As Mr. Bruno said, I am an engineer, and I work for a company. Not that company, or that one. Named Danfoss. But I wanted to kind of describe to you why I'm here today, what my goals are for today. I want to answer all your questions about engineering. No question is stupid. I want to give you advice that I wish that I had gotten when I was sitting in your shoes. And I want this to be interesting and fun. But you should have some goals as well, before you leave. I want to make sure that you understand the value of the classes that you're in right now, whether that's a very high value for you or very low value. You should get a better understanding of, okay, yeah, this is why I'm taking this class. If there's something that you've always wondered about, jobs, school, money, college, whatever, sports, just ask me. It's all on the table today. And I want you to become an active part of the discussion. I hate boring lectures. I don't want this just to be me preaching to the choir. So if you don't understand what I'm saying or you've got questions, just stop me. This is where I talk about myself. So like I said before, I work as an engineer for a company named Danfoss Power Solutions. And we are a global leader in mobile hydraulics. Can you guys kind of pick apart this phrase for me right here? What does that mean to you? What do you understand that to be? Does anybody know what hydraulics are? Not really? Okay, that's good. I'm gonna get to that. But we are a global company. I'm in Ames, Iowa. But we have factories in China, Japan, Slovakia, Germany. We truly are all over the place. And we're one of 3 industry leaders in our field. And we produce mobile hydraulic products. That means hydraulic products that go on things that move, like tractors or road milling machines like this right here. And these are some of the general categories that we make. Don't worry if you don't know what they are. We'll get to that later. Pumps, motors, valves, controls. But most importantly, like I said, what do you think engineering is to you? Can anybody give me an idea?
Figuring out ways to solve problems.
That's pretty good. That's better than last class. Anybody else? Any ideas? Alright, well, dictionary.com says it's the art or science of making practical application of the knowledge of pure sciences, aka pre-calc or calculus, whatever, as physics or chemistry, as the construction of blah, 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 blah. Okay, that's pretty good. I think it's pretty accurate. But most importantly, an engineer, I think, is all of this. You guys have seen these before, right? So, what my friends think I do, Big Bang Theory, anybody watch that? Yeah, I would argue that we are very much a Big Bang Theory type community. A bunch of nerds who all talk the same language together. What my parents think I do? Yeah. Go design stuff, go build buildings. And what society thinks I do? We make a lot of cool new nifty products, I guess. Sorry, buttoned up polos and saving the world. Yes. What girls think I do? That's not what I do. What my boss thinks I do. It's kind of hard to see, but it's like a big 5-armed robot thing with the engineer just collapsed underneath from exhaustion. No, I don't do that, boss. But, oh, yeah. Not that one. No Thomas the Tank Engine. What I want to do. Yeah, I'd say that's pretty accurate. Who wants to design cool cars someday? Yeah, cool cars are cool. What I think I do, land people on the moon, might be accurate. And what I really do, sit on a computer in front of 2 computer screens, maybe a little bit. Maybe a little bit. Okay. Kind of hitting off that last picture there. if you would have asked me if I was sitting in your shoes and I asked you, you want to go design this someday? Do you want to go work on this and build this someday? You'd say, no. First of all, what the heck is that? It looks like a big anchor. And it's kind of ugly. Well, I would have said the same thing. But what I've kind of learned through my engineering career is it's not necessarily about what you make. You know, that's a part of it. Everybody wants to design their own cars. But there's a lot of people out there that don't design cool cars. I kind of liken it to playing in the NFL. Everybody wants to play in the NFL, but there's not a lot of people that play in the NFL. You know, but what is cool? What is cool about my particular product, or could be anybody else's product? What's cool is they go in other cool things like cool cars and tractors and stuff. You know, without us, John Deere doesn't run. Without us, cases, combines don't pick stuff. All these other vehicles in here, you know, they all have components which we produce, which we create, and it's important for us to create them, otherwise they can't meet their customers' need. They can't go do the job that they need to do. And for me, that's a very, very cool, very gratifying portion of my job, is dealing with products that big customers need. So, all right, time to actually teach you something now. So Mr. Boudreaux says that you've had a little bit of physics so far, some of you at least. You're kind of familiar with the topic of like forces. Okay, that's good, that's good. Well, let's not start there. Let's start there. So what I'm going to coach you through is the first kind of lesson in hydraulics. First of all, what is hydraulics? Can anybody take a stab at what hydraulics are? No? Okay, so basically hydraulics is the application of fluid science or fluid physics to meet a real world application. And that's what I'm going to describe to you here. Okay, so I've got all these funny shapes up here, and they all do a very specific thing. First of all, who can guess what this one does? What is that? What is that circle with an M in it? A shaft. A motor, correct. Motor. He's on a roll. Okay. A motor. Okay, so the motor is turning. You can see this is the shaft turning right here, and it's connected to something. You know, this circle with an arrow through it. What is that circle with an arrow pointing out of it? Anybody take a stab?
It's like a gear or something.
Kinda. It's one of those. It's a pump. It's a pump. Which, you know, it's on the same track there. So that is a pump. Now this is where it all starts right here, is with the pump and the motor. So this motor is some electric motor or a gas engine, you know, you name it, and it's hooked up to this pump. Well, what does a pump pump? It pumps fluids, right? It could be water, it could be air. Well, in our case, it's hydraulic oil. Hydraulic oil. And you can see all these lines that are hooked up here, you know, it's some kind of circuit. So there must be some kind of fluid in the circuit. Well, if you follow the arrow, you can see the fluid travel. Whoa. Not really jumped the gun there.
Hang on, I got you.
Alright. Save me.
Keep. Let's see.
Alright. Well, like I was saying, we got some hydraulic oil traveling through these circuits. And basically, it travels around through these various things. Can anybody guess what this big rectangular block in the middle is? Anybody take a stab at what that might do?
It's like the transmission.
Kinda. It basically does what a transmission does, but it's called a valve. And a valve transmits the power to wherever you need it to be. So, like a transmission, which would transmit power to the rear wheels, this is a valve which transmits power and fluid to whatever work function that we are trying to do, basically. So, valve. Oh boy. Just do
the spin doing to the fluid?
What's the spin doing to the fluid? Okay. So basically, our pumps require a rotary motion to create fluid movement. So what happens is, basically, the fluid is sucked in by a kit. And actually, I'm going to talk with, you can come up and talk with me later on this. So it's a fairly complex thing, and it's easier to show you than describe it without some kind of drawing or something. So take this with like a black box attitude. So we're spinning and we're sucking in the fluid from this tank right here. We haven't quite got there yet, but this is a tank. And that's where all, that's where all of our hydraulic oil is. Getting sucked up through the pump, and it's going in this loop, this circuit. Okay, next big thing, what is this over here? Anybody take a guess at that? What if I put this up here? What if I put 100 pounds up here? Does that give you a hint?
It's like a piston.
Exactly, it's a piston, it's a cylinder. Alright, so that cylinder, that's how we get things done, right? So that'll be on your backhoe or whatever type of machine you're using. Alright, well now we need to get the fluid from the pump to the cylinder to raise or lower our 100 pounds. How do we do that? Take a stab. It's with the big rectangular thing in the middle. We move our valve. So what can happen is we put some kind of spring or something here to move that valve down, and now all of a sudden our lines are connected to these guys. So if you follow the arrows, your fluid's going to come through this line and connect to this guy now, because this section is and we got our oil coming into our cylinder, into this space down there. Well, that oil needs somewhere to go, so it just keeps expanding down there, and that moves the cylinder, and it moves our load up. This oil obviously has to have somewhere to go. Can't just stay there in this cavity, right? So that comes back here, next to this guy, and back down here. So now we just created a hydraulic circuit, and a means for doing some kind of work, some kind of backhoe function or something like that. So, all right. That's enough of that. This is probably going to be the more fun part of the class for me. I want to open this up to questions now about engineering, about college, anything that you might have. I kind of came up with a list of questions right here, but I really want to kind of be available to whatever your questions might be. Does anybody have any questions about college? What kind of careers they're kind of thinking about? Where are you guys at in your college decisions right now? Have you guys all picked a place to go yet, or are you still thinking, still searching? How many are still searching? All right, that's good, that's good. You got at least narrowed down to a couple places? Okay, yeah, that's good. Yeah.
What was your most challenging class?
Most challenging class? Boy, for me, there were some chemistry classes in there, just because I majored in agricultural engineering, and it had some to do with chemistry, but not a whole lot. So when I took my chemistry classes, I wasn't super in tune to it, and there's quite a bit of lab work that goes on in your chemistry class, and it requires a lot of pre-writing and that type of stuff. And I just remember being up super late one night writing like a 14-page pre-lab, and I didn't like that very much at all. But actually, kind of to spin off that, this is this was my senior design capstone project, and you can pass it around and thumb through there. So next time you guys think that you have a long report to write, look through that. It'll make Mr. Adams' senior religion design or religion project seem easy. But I would say that was my most challenging class.
So you said you're an agricultural engineer. What kind of jobs can you do other than with Dan Foss where you do pumps?
That's a very good question. So the type of agricultural engineering that I'm in is power and machinery, which is very similar to mechanical engineering. Mechanical engineering, or mechanical engineers are really everywhere in industry, from auto industry to agricultural industry, wind energy industry, and I would say that as an agricultural engineer, you can do pretty much all the same stuff. For instance, several of my friends work at like a John Deere, and they don't deal with this on a daily basis, but they deal with tractors and that kind of stuff. Caterpillar is a big one. Let's see, kind of a really cool one that I thought was kind of neat. There's a place called El Maco, and it's basically it's kind of like John Deere. They make agricultural equipment for combining and harvesting, but they do only very small, like prototype machines for individual farmers. And that means that my buddy, he gets to kind of sit at his desk and like design stuff all day. And I'll be honest, like a lot of my work is design, but a lot of my work is also not design. That's one thing about the engineering profession that I'd like you guys to kind of take away from the day. Kind of, back to our what is engineering. There's a lot of glamour that people associate with engineering. It's not all glamour. There's days where, what I do is really sit at my desk and create like some kind of calculation in a spreadsheet or something like that, basically doing some paperwork. But there's also, a lot of days that I get to design really cool stuff. Or like, for instance, I get to work down in our test lab a lot. And I really enjoy that because it's hands-on, you work with like wrenches and you kind of, you get dirty and you do some cool manual work like that. It's nice to be able to do that. But you can find those types of opportunities pretty much anywhere with a type of degree.
Why did you decide agricultural engineering over any others?
Well, for me, it was kind of because all my friends were doing it, to be honest. Most of you will remember like Tom Nair, the Nair family. Tom was one of my good friends, and we both went to Iowa State. But he decided that he wanted to do agricultural engineering early on. And then I went into college undecided. So I went in knowing that I wanted to do engineering, but I didn't know what kind. And finally I just decided, you know what, I like tractors, tractors are cool, so I'm gonna be an agricultural engineer. Well, little did I know, there's a lot more to agricultural engineering than just tractors. But basically, what I'm trying to tell you is, I didn't know exactly that's what I wanted to do, but I made a decision and I went with it. And what I did with that decision was, I made it work for me. And I would argue that you can do that with pretty much any major. Now, there will be people that come in undeclared, not knowing what they want to do, and they'll switch their major 2 or 3 times. I don't recommend doing that, to be honest. What happens when you go in, you think you want to be an engineer, and then you start doing all this crazy calculus and math stuff, and you're like, no, I'm not doing this. And then you want to become a biology major. Well, now you've got a half a semester's worth, or a year and a half worth of engineering courses that don't apply to biology. So now you're really starting over. So, just be mindful that decision is a big decision. And you want to take your time deciding it, and it's okay to come in undeclared or equivalent like that and get some basic classes out of that. Answer your question.
Yeah.
go back to, not that. That list. Okay. What other kind of questions you guys got?
Alright, so like, do you, because you already like showed us the design, do you actually come up with new designs for different like, things that they come out with, or are you building them?
Yeah, I got that question in last class too, and I'll kind of take you through the same thing. Okay, so, our pumps right here, you know, there's a, if you can bear with me, I'm really bad at this. This is kind of the basic function of our pump. There's fluid in there, right? Okay, now you get your shaft, and then there has to be some kind of seal here that keeps in the oil. All right? Well, a customer came up to us one time and was like, well, one seal is okay, but we need 2 seals. We need 2 seals. Why? Because we have a huge, big, expensive transmission over here that if all the oil drains out of it and we don't know, it's a lot of money, so we don't want to spend that. So we want you to put another seal right there. Well, you would think that'd be pretty easy, right? Physically, it's really not that hard, you know. What I would do is, okay, here's our problem. You know, I don't necessarily go design the seal. I don't necessarily go design the new pump, but I know that, hey, my supplier sells sealed. And then I talk to my drafter. Now, a drafter in my company is someone that we use strictly for 3D modeling. So they're really the ones who go into a 3D model and put parts into place and kind of arrange them so they fit. But my job is to take that seal and make sure that it meets all of our pressure requirements, make sure that it will withstand our shaft spinning fast enough, and then I gotta make sure it fits. Let's see, and basically I have to work with a supplier on, you know, when do we get that seal? How long is it gonna take to get that seal? You know, if we want to build a prototype, what does it take to do that? So what ends up becoming my role as the lead on this design project is making it all come together, making it work, making all the pieces come into place. So I would say to you, yes, we do new iterations of design, but it's not just me going and making this big transmission, or me just going and making this big pump. It's me modifying what we have and making it work with a new customer, making it all come together. And I think you would find that kind of common thread throughout various industries as well. You know, for example, the fancy car example. Everybody wants to build and design a fancy car. It's not how it works. You don't just sit down and design the whole car by yourself. You sit down and you work with the suspension team and you say, okay, what is the proper spring that needs to be in our suspension so that you know, the ride isn't too harsh or the ride isn't too soft or it sits at the right height, you know, it answers those kind of questions. That's one of the biggest takeaways that I want you to have from today is the need to being able to work in teams together. I don't think you guys do a whole lot of team projects now, and if you do, be prepared because they're going to multiply when you get to college. Basically everything, a lot of the things that you do will be team oriented, and you'll be required to work with a group of 4 or 5 random people you've never met before. And you'll have to come up with some kind of assignment and fulfill that assignment together. So. What else? Oh wow, that's nice.
Alright, so
I kind of have a couple questions for you. Like, what type of degree did you get, like a bachelor's or a master's?
Yeah, so I got a bachelor's. Do you guys kind of understand, well, I kind of do, because I don't know if I did at this point, but do you understand the difference between like masters and bachelor's and a minor and that kind of stuff? Good. So I got a bachelor's in ag engineering. But that was, I graduated in 2012. And I work full-time now, but I also go to school part-time still. I'm going after a master's in business administration. And well, yes, why are you doing that? Well, anymore, honestly, a master's degree is becoming the normal type of bachelor's degree. So, for instance, if I wanted to progress into more of a, right now I work on a team of about 10 individuals. Well, we have a team leader who would be my boss. And if I ever wanted to progress into that type of role someday, I would need more of a background in managing people rather than designing pumps. So that's effectively why I'm kind of still in school, getting a little bit higher degree, a little bit different field of study, so I can progress through my career up to those types of levels.
Okay, so after that, when you graduated, did you have to like go to companies and say, I can work for you, or did you have people come to you saying, work for me? And like also, did you intern while you were in college?
Yeah, good question. Okay, so yes, to all of that. So I want to introduce you to the concept of a career fair. So at least that I would say, and from what I understand, it happens at most universities. They'll hold a semesterly career fair for engineering. And what this career fair is everybody gets together in the gym or the stadium, whatever it may be, and companies come from miles around, all over the nation really, and they set up their booths, and you come, and everybody comes and like walks around and like mingles and talks with these companies. Well, the idea is, you give them a resume, and you try to make a good impression. You tell them about all the things you've done and why they should pick you for a job. Okay? When I was, I think that the career fair was a very important thing for me because that's where I started marketing myself, started learning. Now, I will tell you, having now not only been to a career fair, but as an employee, I have gone to the career fair as an employer. And I think it's critical that you go to these things your freshman year. A lot of your friends when you're in college will probably say, hey, why are you going to the career fair? You're a freshman. And, rightly so, but what I would say is that you need to be able to learn to talk to these companies. It's kind of a new challenge when you try to market yourself for something that you'll be getting paid for. So go early and go often is what I would recommend to you. That way your face gets into the employer's mind. You hand them a resume, they put that in their system, they keep an eye out for you. How do I know this? Because that's how I got hired. I went to our fall career fair every year that I was in school as a freshman. And they told me when I was a freshman, yeah, come back in a couple years. So I did. And then my sophomore year, they said, yeah, come back next year, we only hire juniors or seniors. So I did. And then, sure enough, junior year, I went back there and I said, we'll keep you posted. And then come springtime, I was sitting in class and I got a phone call. The phone call was, hey, we want you to do an internship for us. Okay. So all that preparation kind of led up to an opportunity is what I'm trying to say. And that opportunity wouldn't have been there if I didn't put myself out there. So that led to my first summer as an intern. I interned at Danfoss 2 summers in a row. And by that time, it's kind of expected that if you intern there repeatedly, you have a pretty good shot at getting a full-time job. and that's the case, that was the case with this company. You know, I interned there 2 summers in a row, and they were kind of like, so, you wanna come work for us? And I was like, yeah, that'd be really cool. So, after you start marketing yourself, they start to come after you. And that's through internships, through career fairs. So keep your eyes and ears out there for that type of opportunity. So, just take advantage of whatever you can too. You know, don't be afraid that you aren't qualified enough yet. They know you're not qualified enough. They're not gonna hire you as a freshman, but you still need to get the practice and it helps put yourself out there.
How long have you been working at Danfoss?
I've been in and out of there now for about 2 years. So I interned there 2 summers in a row. That's about half a year. And then I've been working there since last January, full time. So nearly 2 years, I guess. A year and a half, more closely. So.
Do you use like the same math every day, or does it like switch up?
Yeah, thank you for asking that. This is what I told the last class was, I don't sit at my desk and do pre-calc all day. I don't sit at my desk and do physics-based math all day. There's a lot more besides the math that you need to know and to do during the daily routine, I guess. I will say that I sit down and I use the concepts that I've learned here. You know, you need to know about differentiation, about integration. For nearly every science-based engineering field that you could be in, you will use that type of math. Absolutely. Are you going to have to remember, you know, how to derive something off the top of your head in 10 seconds or less? Probably not. But you will need to know the concepts, and you will need to know where to get the answers. Because what you'll learn, I guess, through your physics career is all that math describes the physics. I liken math to the ultimate truth kind of about the world. Most things can be described through numbers and through formulas or equations type things, and that's where your math starts to become interesting. It's when you start applying it to your field. But back to our big black engineering screen, you know, you're not always sitting at your desk doing math, crunching numbers. That's one of the, I guess, the beauties about my job, at least that I enjoy, is it keeps me doing a different thing every day. So in our factory, we have many different types of employees. You know, we've got human resources, you've got business managers, you've got sales and marketing, you've got the actual worker who's out on the assembly line building these pumps by hand. And I work with literally every single one of those people almost on a daily basis. And that's where the value of your teamwork comes in, and communication skills. That's another big one that I would say that you guys need to be steadily preparing for. If you got to see the report floating around, there's a lot of communication skills that went into that report. There's a lot of communication skills that I need to do or work with on the daily job. For instance, one of the biggest challenges for me right now, we have Chinese coworkers in China, and they pretty much only speak their native language. Their English is very minimal. They can read, but not read necessarily well. So, for instance, on the SEAL project, the drafter that's working on this project is in China. So that means I can communicate with them once a day because they're on an opposite time schedule. And if they put the seal 1 millimeter too far this way or 1 millimeter too far that way, I have to email them or somehow communicate that to them that, hey, take this and move it this amount. And they may or may not comprehend that depending on how adequately you describe it to them and that kind of thing. So developing that kind of understanding of both cultural barriers and languages is very important. So it's not just math. Others?
Did you get to study abroad?
I had the opportunity, but I declined because of the sports. It was, I would have really liked to do that. It's probably one of the biggest things that I probably missed out on, but it just wasn't really possible, to be honest with you, at the Division I level.
Where would you have gone?
You could have gone to Ireland, you could have gone to Costa Rica, you could have gone to Spain, just literally everywhere, anywhere that you could think of. They've got a program for it. I would highly encourage that. Actually, many of my classmates and coworkers have done it. I've only heard positive things. So take advantage of that while you can.
So is football really getting away from your studies?
I would say no. Now, that's another big plug for Allman here. Most of you are probably involved in some kind of sport, some kind of after-school activity, some kind of play, something. You probably are doing something outside of class. So what do? You get out of class and you go do your activity, then you go home and you probably do homework and go to bed. And I would argue that it was the exact same way for me in college, and I was okay with that. I was ready for it because Allman prepared me through that. And I still had plenty of fun, trust me. I had lots of fun. But by staying focused and carrying on kind of a focused mentality that came from here to these kinds of classes, you won't notice the change as much. You'll be ready for it. So.
Do you think the work ethics you gotta use at a Division I level for football help prepare you for the work world?
Absolutely. In all honesty, my boss, my first summer that I interned, said, "You know why you got hired? It's because you kept coming back. It wasn't because I had the best grades. I wasn't number one in my class. You know, I was not average, I'll tell you that. I had good grades, I was above average, but you know, when somebody's comparing two identical resumes, you know, who are they gonna pick? If every single line item on the resume is the same, who do they pick? They pick someone who they know has had experience in tough environments, who has been able to show that they've worked hard to get where they are, and that's exactly what sports did for me. For instance, how's this? Putting the head coach of a Division I football team on your references list. That's pretty good, even if we've lost 6 games, 7 games. But anyway, even that kind of stuff, it all adds up, it all helps, and I would argue that I am where I am exactly because of the sports and heavy, I guess, workload that I've been through. So.
What was it like walking on a Division I program like that?
It was a challenge. Number one question I think I got asked was, you know, how much should we get hazed or something like that? And it's really not as bad as you think. You know, when I kind of said that when you go to college, you get to be whoever you want to be. Well, everybody else is getting to be who they want to be too. And so, if you, I don't know, if you always got made fun of or something in high school, they don't know that and they don't care. You're starting those new relationships and they just want to do their own thing just as much as you do. So I think that made it easier. But I will tell you that, you know, they don't single you out necessarily, but there's pressure on the walk-ons to perform, because if you don't perform, then you're gone. But there's also immense respect because, you know, we don't get paid. And so that type of work ethic you show really pays off in the end, pays dividends.
I was gonna ask why you picked Iowa State, because I know that's an engineering college, but why did you pick it if you were undecided?
Right, so basically I ended up picking it because of football. They were the ones that were showing me the most interest. Other colleges that I looked into Purdue, I looked into Northwestern, Washington University in St. Louis, all big heavy hitters when it comes to engineering. Could have probably been successful at any one of those, but after I made a couple college visits to Iowa State, got to know kind of what the culture was there, I was like, hey, yeah, this is where I want to be. And that's something that you just kind of know. For those of you who have already decided, you probably know that feeling. It's like, hey, yeah, this place is pretty cool, I want to go here. That's awesome, that's what you're looking for. But if you are still undecided and you know, you're really on the fence, all things being equal, remember, if all their resumes are equal, pick the one that you know you're going to be most comfortable at, because you will be successful there. There's no college out there, I don't think, that you do not have the chance to be successful at.
What's your stance on a big school like that? Because I've had people tell me that, you know, you go to public university where there's 30,000 kids, you know, the teachers don't really care, as opposed to like St. Ambrose.
I would say it's definitely a big change from Allman. Because there's definitely some of that out there. There's definitely, you will be, if you go to a major public university, you will be in a classroom with 300 other kids, one class, you know, and then there's 3 or 4 sections of that same class. And that's where you really have to be able to work on your own. But there's also help that they give you, and you have to be smart about it, like tutors. There's tutors out there that really help that out. And something that's unique to college classes is, that you guys haven't experienced yet, is, so you've got this 300 kid class. Well, how do you teach all those kids, obviously? So basically you'll meet for that class on like Monday, Wednesday, Friday in the lecture hall. And then on Tuesday and Thursday, you go to a classroom like this with a TA that can answer individual questions and basically do everything that like the teacher here would be able to do. So there are ways they combat that, but at the same time, if you don't take advantage of it, you might struggle a little bit. I'm happy that I went to such a big university. I like the feel of it. But I think I also would have been okay at a place like Ambrose or something like that. They've definitely got a pretty good education program over there. It's all kind of about what your comfort level is. You guys hungry? You ready for lunch? It's Friday. Are you out of here? If you want to come, if anybody wants to come up and look at these pumps, I'll kind of describe to you.